All right, hello everybody, and welcome to the last part of ultrasound transducer management. So we covered knowledge of transducer components, frequency relationships, and transducer selection, 2D array transducer concepts, and in this last part we're going to cover 3D and 4D concepts. So let's go ahead and get started. All right, so the question we're provided with is, improvements in Principle 2 virtual beam forming include reduced section thickness, which improves what? A is axial resolution, B is lateral resolution, C is elevation resolution, and D says all are correct. Well, again, the correct answer in this one is going to be elevation resolution. And so this is correct because section thickness refers to the dimension of the beam in the elevational plane, so the slice thickness. And then when this section is reduced, the beam becomes thinner in the elevational dimension, so less out of plane echo formation is included. And slice thickness artifact is reduced, and so that directly improves the elevational resolution. So let's go ahead and talk about the other answers and why they are incorrect. So A said axial resolution. Axial resolution depends on the spatial pulse length, and it depends on frequency. So it's not affected by section thickness. B said lateral resolution. Lateral resolution depends on beam width in the imaging plane and depends on focusing. So section thickness is perpendicular to the imaging plane. And D was all are correct. Obviously, that can't be correct. So only elevational resolution is improved. Axial and lateral resolution are controlled by completely different factors. So a good way of putting all this together, axial, think pulse length, lateral, think beam width or in the plane. If we're talking about elevational, think section thickness or out of plane. And again, since this question mentions reduced section thickness, the answer must be um, elevational resolution. Okay, so the next question is going to be, elevational resolution can be considered a third aspect of detail resolution. This is a true or false. And again, the correct answer is true. So detail resolution, which is also called spatial resolution, has three components. It has the axial resolution, lateral resolution, and the elevational resolution. Axial resolution, again, it's along the direction of the beam, and that's determined by the spatial pulse length. The lateral resolution is this side to side in the imaging plane, and that's determined by the beam width. And elevational resolution, so that's slice thickness, right? So it's out of plane dimension, so determined by section thickness. And because elevational resolution controls uh, how we distinguish structures in the third dimension, it's absolutely considered. Let's talk about if you looked at this from the false perspective first. So, and we'll work backwards to disprove that. So, if elevational resolution were not part of detail resolution, we could ignore slice thickness artifacts, but those are very real and clinically important. So, poor elevational resolution leads to out of plane echoes, and that leads to reduced image clarity. And the big picture is, think of resolution as 3D, so front to back, axial, side to side, lateral, and then up and down, think of thickness or elevational. So all three together determine the overall detail resolution. Okay, next question says, operating principle number 2. Virtual beam forming greatly improves axial and elevational resolutions as compared to resolutions in principle 1. So A is true and B is false. Again, the correct answer here is false. Um, so principle 2, which is virtual beamforming, that improves elevational resolution by reducing section thickness, and it does not greatly improve axial resolution. So let's go ahead and separate them. Elevational resolution um, is improved because section thickness is reduced, so less slice thickness artifact. Axial resolution, um, that's not significantly affected by axial resolution because it depends on spatial pulse length, frequency, damping, and virtual beamforming does not change pulse length. So again, axial resolution remains essentially the same. And why the true statement is incorrect, why it's not true. The statement claims both axial and elevational resolutions are greatly improved. So only elevational resolution is significantly improved. Axial resolution is controlled by entirely different factors. So again, think axial pulse length, lateral beam width, elevational section thickness. And this is principle 2, which mainly improves elevational resolution, not axial. All right, I want to thank you very much for listening to this short video on transducers, 3D and 4D concepts. If you notice my head kind of moving back and forth, I'm trying to center my head so it looks even, and so I'm not leaning like this, but that's why my head is doing this. Again, see you on the next section, and thank you for listening.